When you solve a quadratic equation by graphing, you have different possibilities. You could get one solution. That is, the parabola comes down and touches the x-axis. It could be like the problem we just did where it crosses twice. So you get two solutions. If it never intersects the x-axis, there's no solution. So now let's take a look at a problem. On example 2, notice what happens here. It doesn't equal to 0. We have to make it equal to 0. We have to do the related function first. So what we're going to do is we're going to just move that negative 4 to the opposite side. So we're going to say x squared minus 4x plus 4 equals 0. We're going to graph the related function f of x equals x squared minus 4x plus 4. Let's go ahead and graph that. So f of x equals x squared minus 4x. I don't know why I got a parentheses there. Let's delete that. Minus 4x plus 4. Notice on this one, our parabola only touches the x-axis at one point. You have one solution, so x equals 2. Now if we take a look, take a look at example 3 here. We have an application problem. It says use a quadratic equation to find two numbers with a sum of 4 and a product of 5. Well, let's start with the sum of 4. So let's say my first number, I'm going to call x. My second number, since they have to add to 4, that would be 4 minus x. So if I add x plus 4 minus x, I get 4. Product means they multiply. So in other words, we're going to take x times 4 minus x, and that's going to equal to 5. Now if you want to rewrite this, we can. Let's distribute that x inside, so you get 4x minus x squared equals 5. I don't like my x squared being negative, so what I'm going to do is I'm going to take this entire side, I'm going to move it to the other side of the equation to make it positive. So we get 0 equals positive x squared, because we're moving it to the other side, minus 4x plus 5. Now let's graph that. So f of x equals positive x squared minus 4x plus 5. Notice our parabola never crosses the x-axis, so there is no solution to this problem. We probably could have figured that out in the beginning. There is no way you can find two numbers that add to 4 and multiply to 5. It's just not possible. Now, what happens if it's not a nice whole number? Well, we can estimate by looking at the graph. Now, obviously, if you click on it, Desmos will give you a rounded decimal. That's what we're saying. On this question, and this is what comes up on tests sometimes too, is I want you to state the consecutive integers which between the solutions are located. So here's what we're going to do. We're going to graph, just like we did, negative x squared plus 4x minus 1. So we're going to go negative x squared plus 4x minus 1. Notice since the leading coefficient is negative, it's a sad-looking parabola. Well, what happens here is my solution is between 0 and 1. You see that it's a decimal. The rounded answer is 0.3, but it's between 0 and 1, so that's what we're going to answer. We're going to say, oh, my solutions are between 0 and 1. And then we're going to look at, where's the other solution? Well, that looks between 3 and 4, doesn't it? So between 3 and 4. Now you can solve a quadratic equation besides graphing by making a table. So here's what we're going to do. When we look at a table, we're going to look at when does it equal 0. And we want to round this answer to the nearest thousandth. So here's what we're going to do. We're going to make our table. So on Desmos, I click my plus sign and I click on table. Notice they use x sub 1 here versus just plain old x. I don't know why they do that, but that's what they do. So we're going to say x1 squared plus 5x1 minus 7. Now we're going to do some guessing. I'm going to look what values of x do I get 0? So I'm going to start here. I'm going to go 1. And notice I get -1. If I go 2, I get 7. Oh, it's between 1 and 2 because 0 is between -1 and 7. So now let's guess the number between 1 and 2. So I'm going to go 1.5. 1.5 is 2.75. 1.6. Notice it's getting bigger. So it's not between those two. I want it to get small. I want to go towards 0. Let's go 1.4. 1.4. That's 1.96. I'm going in the right direction. 1.3. That's still positive. 1.2. Still positive. 1.1. Oh, there we go. So it's someplace between 1.1 and 1.2. So let's go 1.15. That's positive. So let's go backwards. 1.14. That's negative. Barely negative, isn't it? I'm getting really close. So let's go 1.145. Well, that's positive. 1.144. That's still positive. 1.143. That's positive. 1.142. That's positive. 1.141. That's positive. So 1.140. 1.140. That's essentially 0. -4 times 10 to the -4th. So it's really close to 1.140. So that's what we're going to say. So we're going to say, oh, that's approximately 1.140. Include the 0 because you're rounding that. If you just put 1.14, you're saying the answer is to the nearest hundredth, and we wanted to go to the nearest thousandth on this one.